Thank you all for joining to our first call of the Target 2023. It's on 5G and media, all we need to know. I'm David Vargas, I work for the BBC, and I'm chair of the 5G-MAG Content Distribution Technology Working Group. So before we jump into the presentation, into the technical presentations, we wanted to provide a bit of background on the 5G-MAG reference tools, as well as the framework for the Target 2023. So the 5G-MAG reference tools develops open source reference tools to support the implementation and interoperability of 5G media technologies. It's important to say that this is an open community. So both 5G-MAG members and external members are welcome. Developers are welcome to join and contribute. These reference implementations can be used to validate and verify the technology, and can as well be used for prototyping, trials, or even potential deployments. One important thing we do is we link together standardization experts and developers, so that exchange of information is very important. And this is done with an IPR-friendly license model. So the 5G-MAG reference tools have already delivered, so there is already features implemented. Also, I would like to mention that all these the presentations today are being recorded. So, and all the presentations will be also stored in the website, so you can go there and you will be able to find information and then look more into the detail. So here we have put just some of the features initial that have been implemented on around 5G broadcast, and these technology features enabling some of the use cases, such as seamless switching between broadcast and broadband. So this has been already work ongoing, delivering results, and today we are here to talk about the Target 2023. So I'm going to explain a bit the scope and what are the steps. So the goal we have now is to select 3GPP technology features to implement in the 5G-MAG reference tools that enable use cases that are relevant for the industry. So how are we going to do this? So today we have an overview of 3GPP technologies that are relevant for media. And after this call, we are going to open a call for use cases, and this is going to be open to everyone. All this process will be open. There will be one stage that I will explain later that will be only for 5G-MAG members, but you are all welcome to contribute. So we are looking forward to your inputs. So once we have these use cases from the industry, then we will do an exercise of prioritization and selection of these relevant use cases and technologies based on the support and the effort. And once we have this list of technologies, then we will communicate to the public and the developer community. After this, the implementation work will start. So a bit more detail on dates on the next steps. As mentioned today, we have the call one on this information. The idea is today is to share what are technologies relevant that then companies can start thinking about building use cases. So we expect to have as many inputs as possible. So please consider submitting your use case. And then call number 2 and 3, call number 2 on the 8th of July, we will use these two calls to allow for discussion, to allow companies to clarify on the use cases, as well as put in more detail, starting to understand what are the technical features that enable these use cases. So this will be call number 2 on the 8th of July and call number 3 at the end of July. We still need to clarify the date. So once we have this all more detail about the use cases and the technology components, then we will do an internal 5G-MAG prioritization. This will be the only part that will be only for 5G-MAG members, but the rest will be open to everyone. So once we have done this prioritization, then we will present in the call number 4 in August. We will confirm the date soon. We will present this to the development community, and the idea as well, and the target is also to present it in IDC 2022. So without further ado, what's today on the agenda? As I mentioned, today the idea is to we are very lucky because we have 3GPP experts that have been contributing or are driving a lot of these technologies that are being developed. So today the idea is that to provide this introduction, so it can be useful for the next steps. So first, we will start with 2 presentations targeting Release 16 features. So we will start with 5G media streaming, an introduction by Thorsten Lohmar from Ericsson and Frédéric Gabin from Dolby, as well as 3GPP SA4 chair. Then, as well on Release 16, we will have a presentation 5G media streaming, dynamic network quality of service policies by Thorsten and Imed Bouazizi from Qualcomm. And then we jump into the presentations discussing Release 17 features that they just have been finished by 3GPP in the last plenary last week. So we will have a presentation on 5G media streaming over eMBMS by Thomas Stockhammer from Qualcomm and Richard Bradbury from the BBC, and then a presentation on edge applications for streaming by Imed, Richard, and Iraj Sodagar from Tencent. So after this, we will have a presentation on 5G multicast broadcast services by Richard and Thorsten. Another interesting presentation on event exposure framework by Richard, Chales from Qualcomm and Imed. And we will conclude with a short presentation on extended reality by Thomas and Frédéric. So once we have these presentations, we will just use the last 5 minutes to explain what are the next steps towards the call to. What do you need to do to submit your use case? And we will provide more information. So without further ado, then I would like to invite Thorsten to make the presentation. Thorsten, hello.
Hello. First, can you hear me?
Yes, we can hear you. Thank you.
Great. So then next question. Can you see my slides? Can you see my slides?
Yes, we can see. Thank you.
Great. So then let's get started. Good. Hello. My name is Thorsten Lohmar. I'm working for Ericsson Research. I contributed to these 3GPP work on definition of 5G media streaming. Of course, there was a bunch of other people involved. So today I have the pleasure to present what we have done in Release 16, but please bear in mind, I'm just presenting what has been done. I've contributed, but it's contribution of many people. Frédéric can unfortunately not make it today, but yeah, that's life. So this is now an introduction to 5G media streaming. So we see today there is lots of HTTP-based streaming out. I would say majority of video services use HTTP-based streaming today. Of course, still there's other type of services ongoing. There's lots of things solved from the encoding, from video on demand, from live, from encryption, and so on. There's also kind of work ongoing and done on device synchronization for playback and so on. So, of course, one key question is, what's left? It's working. The interesting thing is, of course, when looking into the into BitMoveIn developer report from 2021, there are some interesting figures, very interesting to read. Last year, cost controlling was still kind of the high thing. This year, or in the last report, live low latency is more higher. So obviously the industry starts now moving into, I would say, moving from video on demand into normal live video into live low latency video to kind of get real, would say, experiences for instance, for sports services. The definition of low latency, it's of course interesting. At least when I hear low, typically I think in milliseconds, but here low latency, the majority of folks think that less than 3 seconds latency is enough, path latency is enough, kind of followed by less than 5 seconds. Of course, there's also some people focusing on latencies below 1 second, but that's kind of the order of magnitude to kind of get reached in order to claim this is now low latency live. From the metrics, that's also interesting. The video services are monitored, and the last years, the video startup time was kind of key. Now bitrate delivered, so the quality and so on, it's more important. So by combining low latency and bitrates, it's of course then the question, how do you figure out at what bitrate can you stream and what is happening in the network, what is possible, right? Okay, but that was a bit of the background, the guiding things, what has been done in 3PP. Now jumping to 3PP. The 5G media streaming architecture. It has been done a new attempt in release 16. Of course, 3PP has been working on Dash, for instance, since 3PP release 9, so a very long time. But there, the focus was very much on formats and so on. Now for 5G, we started focusing on a framework type of approach, where the idea is to integrate a bit better between networks and the application provider. So here on the left side, it's the general application service layer architecture, which is kind of seen. The 5G-MSD client is basically subdivided into 2 components, 2 functions. One is the media session handler, the other one is the media player. And of course, the peer for the media session handler is the 5G, so-called 5G-MSD AF, which is more control related and so on. And the media player is kind of interacting directly with a 5G-MS AS, which is a bit more like a CDN type of thing in order to get information. Here in this illustration, everything is kind of illustrated in one data network. Later on, I present some deployments, so what is possible to combine it and so on. Here on the right side, we see a high-level call flow, a simplified call flow, how it would work. So there is a concept called a provisioning session, what is basically running during the entire lifetime time of a streaming session. This is basically just that the network is aware about, would say, something is happening. Then, of course, at some point in time, content can be ingested, so uploaded or live ingested into the 5G-MS AS. So that's basically the CDN part. But the ingest is, of course, independent from the reception, from the unicast reception. So information is basically provided to the 5G-MSD aware application to basically become aware about the service. And then in 3PP, there's some APIs defined, M6 and M7, to interact with the 5G-MS client in order to activate the reception. In particular, the M6 API here on the left side should be used between the application and the media session handler. This is basically to start getting access to the information. And of course, the media session handler can then interact with media player in order to kind of get, for instance, a media streaming going to get information from the media player, like kind of metrics reporting, like information and so on. The interesting thing here is in step 7, the media session handler in the client is interacting with the media AF, while the so that's a 5G-MSD AF, while the media player is interacting with the media with a 5G-MS AS. And this is more kind of like that control versus user plane. I explain later on a bit more about this. Yellow basically in this drawing indicates these functions are in scope of the 3PP specifications. It does not mean that you must follow the specifications here. So for instance, it's completely fine to basically use the formats from the 3PP specification and use, let's say, a 3GP dash player. But it's equally okay to focus just on the media session handler and kind of work with other type of streaming technologies. So in that sense, in particular, the video codecs and formats, there's a bunch of optional things. And the focus here is how to interact and not that everything is kind of shipped in one box. Right. Kind of the interesting focus now is on these functions. The interactions with the media session handler and the 5G-MSD AF. There is different type of interactions what can be done on this level. The interesting thing here is the 5G-MSD AF can also interact with the NEF and the PCF. So these are two 5G specific functions. One is the network exposure function, in particular more for external interactions, while the PCF is more kind of internal for local interactions. So in particular, this M5 interface is kind of newly defined in 5G-MS. M4 is very much kind of the normal existing streaming services like Dash or HLS. And M8 is a kind of not further specified interface. So it's basically, there's many information what needs to be exchanged. There is of course kind of the concept of an application on the UE side. So the focus here is what 3PP has done here is kind of to specify a new procedure for specific network interactions between the media session handler and the 5G-MSD AF. In this drawing, of course, it becomes a bit of a question. Why can't this media session handler talk directly to the NEF? Why is the AF in the pass? Here it's a bit of a summary why this is done. This NEF API is more a backend API, which is used more for service providers. It supports isolation of different backend systems. So when different type of providers use the same, interact with the same system, it's basically possible to isolate these two application service providers. But of course, it is really a backend interface because it allows visibility and operation of kind of all UEs. So there is no isolation between UEs. So it's really providing a holistic view on the resources from this application service provider. Of course, as an input here, something what is called service data flow filters are necessary. And here you need to bear in mind a 5G system or in an end-to-end IP pipe. There is lots of connection sharing ongoing. Of course, you may have a single application on a device, which is rather seldom. So quite often you have multiple applications on a device. So the connectivity is shared among multiple applications on one device. And of course, towards your application servers, there's also the traffic from multiple applications reaching the same application server. So these service data flow filters enable the unique identification of the traffic flows, which are then subject to be kind of interacted with from the system side. The M5 API between the MSH and the 5G-MS AF, it supports, basically it's a front-end API. It supports isolation of UE applications, so even isolation of UE applications on the same device. So it is really kind of designed in such a way that this application can only influence parameters of the own application and not really modify parameters from other applications on the same device or other parameters from other devices, right? And here the idea is that these UE applications also provide the service data flow filters and policy information towards the network when accessing CDN services or services on the network, right? So from the collaboration model, as indicated in 3PP, we have thought about different type of collaboration models. Of course, an existing model today is an OTT type of model where everything is deployed in an external data network. Equally valid is an telco CDN where these type of functions are deployed inside of the trusted domain. Trust domain does not necessarily mean kind of inside of the operator network or not. It's really more about the trust who is managing these type of functions. So it might be even an external data network, even if you run it on premise of the telco, but probably outside of the trust domain. And here, of course, the concept is the twin between 5G-MAG AF and media session handler controls the interactions from the application with the network, while of course the combination of 5G-MAG AS and media player, they provide the CDN type of connectivity. One thing is to consider when the installation, the 5G-MAG AF is deployed in an external data network. There's of course not so much trust in place, and in that sense, of course, the 5G-MAG AF needs to interact with the network exposure function using the NEF API. It's a bit more limited compared to the PCF API, but of course the PCF API, it's only kind of considered to be open up for trusted type of things. And this is kind of one of the key thoughts why we are mixing or thought about this mixed type of collaboration. So the idea is to enable access to network services without breaching kind of an end-to-end privacy context. So it's completely okay to run fully encrypted traffic then between the application server and the client. The application server is then kind of also outside of the trust domain, so in external domain. But in order to simplify the interactions with the network, the concept here, or one deployment, is that the 5G-MAG AF is operated, for instance, by the operator directly, in order to simplify the integration with other network functions to get access in an easier way from the network. One of the issues here is, of course, quite often there's a nut in the path between the client and external things. So in particular for IPv4, this has been done due to IPv4 address shortages. But of course, there's also security things on, so to basically hide a bit which device is doing what to kind of reduce traceability of the device and so on. Not sure how is it going to evolve with IPv6, because there these IP address shortages kind of a bit different. But that's of course something to consider, that quite often a nut is in the past and certain things become a bit complicated. There's additional collaboration scenarios defined. However, I think these are illustrating the key deployment scenarios, collaboration scenarios, which can be also used for the subsequent work. Now, from a functionality side, Release 16 is supporting different type of functions. There is video on demand and live support. There's uplink streaming support. There's different deployments like telco CDN or OTT CDN. In particular, of course, for telco CDNs, content hosting is important, meaning to upload content into CDN or into this system, or to basically make access to the content through that system. What is kind of interesting, and I will talk more about in the next presentation, is about this dynamic policies, for instance, premium costs or charging policies. This is very much about, let's say, when an SLA, a collaboration agreement, is in place between the operator and the application service provider. Then kind of it's not only a best effort pipe anymore, certain type of things become possible, but then of course other information is necessary, for instance, to identify the traffic flow. Beside that, there's also consumption and metrics reporting supported, and also network assistance to a certain extent. And then in Release 17, this is just about completing. There is extended data reporting. We've started working on integration combination with LTE broadcast or eMBMS or LTE-based 5G broadcast. And there's also this combination with Edge. For release 18, what is already planned, is identified, is we need to work more on the combination with 5G and 5MBS, so the 5G version of eMBMS, because we're pretty limited in time, and therefore we said, let's do this in release 18. There was already discussions ongoing about new protocols like HTTP3 Quick. Enhancements for live streaming is already identified, and I think this is now looking into the needs from the developer side or from the industry side, spot on. New codecs will come up, background data transfer will be in content-aware streaming, traffic identifications, and so on. So there's a bunch of things, what is planned. Yeah. Right, just if you want to read more, there's a bunch of SA4 specifications, they are freely available. The main architecture, the general description of the architecture is in 501, 26.501. The protocols is in 512, and then kind of anything around profiles, codecs, and formats is then basically in these three specifications, a bit separating audio and video. Right. That was it, what I prepared as an introduction. I hope it was clear, but if there's any question, please.
Thank you, Thorsten. So we maybe have time for one question. Is there any question? We will allow, after each presentation, we will allow a couple of minutes for questions. I didn't mention before. Any questions or comments? Okay, otherwise, so I think, well, the next presentation is you as well, Thorsten?
Yep, I think so as well.
Thank you. So if you have any questions, colleagues, just after
exactly.
the presentation, sure, thank you.
Well, why kind of afterwards, I'm still available. Can you see these slides now?
Yes, thank you.
Great. Okay, so now this is a bit of a dive into dynamic policy. I explained it a bit earlier. This is now a presentation together with Imed, who has also worked extensively on this topic. And the idea here is now to explain a bit more what has been done, what does it actually mean, and so on. So now, first, this dynamic policy invocation. This is about, let's say, adding, modifying, or removing different type of traffic treatment policies, I kind of call it here, on a need basis. The key driving use cases, of course, to improve the quality of service, meaning kind of to provide a higher traffic handling priority in order to get a higher bit rate, for instance, or certain characteristics. These type of things generally require a collaboration agreement between the application service provider and the 5G system provider, because of course resources are used a bit differently, and in that sense, the general assumption here is kind of something needs to be in place between the operator, between the service provider and the system provider. Some example policies here is, for instance, quality of service to increase the traffic handling priority, for instance, for a premium service. Another example would be, for instance, a bit more on background service. So if you know that this is something what is not continuously consumed, you may kind of want to decrease a bit the priority. And the other one is, of course, there's a bunch of different charging policies and so on, and different type of things in place which is impacting the traffic charges, which can also be modified. Right, so I have now a bit detailed examples on these three use cases. But first, this information is done a bit in this perspective. So as indicated, this dynamic policy invocation, this is an on-demand, on a need basis thing. So here the concept is that the application on a need basis uses M5 API to interact with the 5G-MS AF in order to indicate, okay, now I need to have a certain policy, because because of the certain use case. The device provides information with it, like the service data flow description, so which traffic flows should be treated according to this policy, what type of policy should be provided, and so on. So there's a bunch of information what's provided. The backend, so the application provider or application service provider, of course, has done upfront some provisioning. So there's information available about what policies are available, what policies are allowed, and so on. So there's information in the 5G-MAG AF to support the 5G-MAG AF to figure out how to create the system calls towards the 5G system. And afterwards, after this request comes in, the 5G-MAG AF is basically using the backend APIs to the 5G system in order to start applying, to start requesting the needed policies by using the according API calls which are available. And of course, depending on the network, depending on the deployment, it might be an interaction with a PCF directly, with a 5G directly with some network functions, or in some cases to interact with an F or other type of network functions. So in concept, this 5G-MAG is combining the request, and it's of course kind of also doing the isolation of between UIs. So here kind of on this leg, it is truly a backend API call, while on this M5 leg, it is truly an application level isolation of the information. Right. Now, first example is premium costs. Here, the guiding use case is that the service provider, the application service provider, wants to offer a video service with 3 different quality ranges. So 4K, HD, and normal SD operation. And of course, kind of users with the HD service subscription should only access the content in HD quality, up to HD quality. But of course, anything below is possibly depending on the situation. It might be, of course, that you still get SD quality even if you have the HD subscription. But of course, 4K should be restricted. That should be that is outside of the subscription bucket. Here on the right side, it's basically indicated what type of parameters are needed. So on the M5 side, the UI, of course, when requesting information, the UI should provide, for instance, a policy description and so on. No, that's for the service announcement. The UI should become available, what policies are available, in what conditions to use what policy, and also to find information on how to access these services. And when actually activating such a policy, the UI should provide the a policy template identifier and some other information with it. In particular, of course, the UI should identify some information on the traffic flows which should be treated according to that policy. And here again, bear in mind, it's a shared network. There's multiple traffic flows ongoing, and not everything should be treated according to that policy. So that's kind of easy to understand. You want to have premium costs, and of course, in that sense, it should boil down to have an according cost bearer, which is basically ensuring that you get the needed bitrate for that service quality. And of course, you should only get the quality of service, what you actually need for your operation point. So when you have an HD operation point, you should not get the quality of service for a 4K type of stream. Right. The next use case is more a conditional zero rating. So the idea here as a concept here is that the sort of an conditional zero rating is possible. So basically the service access is free of charge or low of charge when the quality is below a certain threshold. So for instance, even if you have a certain high quality service available, the user basically accepts to watch the content only in HD or in a lower quality in order to basically leave space for other users and so on. So here the idea is that the information is provided to the UI. Some sort of policy information is provided so that the on one side the dash player knows, or the media player knows, it should not go to the highest possible quality. It should only kind of go up to a certain level of quality. And of course, the media session handler is provisioned in order to activate, in order to notify the network that now the client is consuming content compliant to this policy, meaning the client is fetching content which is always below a certain policy threshold, right? And of course, the result out of this would be then a different type of charging rule, charging condition would be applied to that traffic, right? The third case is we call it background download. So today in many streaming applications, you have the possibility to select an offline consumption. Of course, the initial design was you prepare yourself at home, you collect, you download a certain set of assets, and when you have no network connections anymore, you basically have the device preloaded. On the other side, of course, from a convenience perspective, it might be also interesting to run similar thing on a wide area system, on a public network, for instance. But here the concept would be that if you download something, the benefit is you are less prone to, would say, bitrate variations. And in principle, you can download the stuff at a lower bitrate, but then still have a convenience of a continuous watching afterwards. And here again, there's a set of parameters identified, listed, what is actually needed to activate the service. Right. Last but not least, and now it gets complicated, this is now a walkthrough of the parameter population. So in principle, it starts on the left side with the provisioning side. So on one side, of course, the application needs to be provisioned. Let's take this HD premium cross case again. The application is provisioned somehow to indicate, okay, this application can only get up to HD quality, but not 4K quality. Then here in this step, the system needs to get provisioned to understand the relation kind of what quality of service to ask for when a certain quality representation is requested. For instance, when the HD quality representation or when the HD quality subscription is requested, then of course a certain network policy should be activated towards a 5G system. Last but not least, of course, the manifest needs to be conditioned in some way, because also here the dash player or the media player in general needs to understand it doesn't make sense to go to, for instance, 4K resolution, because 4K is not allowed. So it can be a general manifest, which is basically augmented with additional information, like we call it here operational ranges. To tell the media player what is an acceptable range of operation. So when the user has an HD subscription and the manifest contains representations up to 4K, the operational range basically says the device is allowed to, the media player is allowed to fetch anything from SD up to HD, but 4K is kind of prohibited. Of course, this is kind of the provisioning side of the backend system. And this type of policy descriptions needs to be provided to the media session handler, so that depending on what is actually selected, and here there's some interaction with the media player and the media session handler. So depending on what representation, what quality is actually fetched, that the according dynamic policy instance is activated and the according parameters are provided to the 5G MSD system. This, of course, enables then that the 5G system is able to identify which traffic flows should be treated for the high quality. For instance, what traffic flows is subject to be treated with HD quality, and which other traffic flows are completely different applications or are other type of information, right? Here's a bit of a description of what I just verbally explained. We don't go through this again. If you want to kind of read this up more, it is described in some level of detail here. And yeah, you can also find more of this. So this, for instance, is information which contains in an annex of 26512. So the idea here was to give an introduction of what these dynamic policies are intended for, what can be done with it. And yeah, as indicated in my first presentation, the idea here is to enable a better collaboration between the application service provider, for instance, the video service provider, and the actual network provider in order to provide an improved quality of service to end users. Right. So that was it. I hope it became at least a bit clearer what this dynamic policy is about. And again, I guess we can have one question.
Hi, Thorsten, thank you. So there are some questions on the chat. I think what we are going to propose is maybe if you can maybe reply on the chat directly, and then maybe we can progress with the other presentations. But thank you very much. Very interesting presentation.
Will do.
Thank you. So let me check our next. So we have our third presentation, 5G media streaming over eMBMS, Thomas Stockhammer and Richard. I think, Thomas, you are presenting this one.
Yes, yes. Hello, can you?
Thank you. Yes, we can hear you and see you.
Okay, excellent. So now I just need to share my screen and then we can start. Just make sure that I open the. Thorsten was too quick. Share my screen. Okay, good. Okay, so first of all, thank you to Hori and David of setting up this environment. And as Thorsten introduced and we started, I believe there's a lot of value not only for the people who are today the recipients of this information. We as those who work regularly since many years in 3GP on developing specifications for the media industry really benefit from the exchange of information with the colleagues who implement in whatever framework. And so it should not be one directional. Yeah, we hope that this is kicking off a process for feedback. Specifications 3GP are final at a release date, but they are never perfect. So there is always an ability to fix specifications, and there's multiple processes. For example, you can create change requests, you can create new work items, and so on. So we hope to make this a more regular exchange with developers, and the open source environment is really probably one of the opportunities to have an open discussion. So let's continue doing this. So in particular, one topic that we started in release 17 was doing 5G-MAG via eMBMS. And that sounds cryptic, but I have a bit of background here. So the slides are developed together with Richard, who was also very instrumental in developing this technology in release 17. We completed this a couple of weeks ago. So what is the motivation why we did this? Basically, we have LTE-based 5G broadcast defined in the ETSI spec. 5G-MAG is a bit of the owner of this one. And that is based on 23246 and 23246 and 23346, which are the SA2 and SA4 specification. And what was done, LTE-based 5G broadcast is basically built to address the 5G requirements for broadcast, but it's built on top of the enhanced packet core and not on 5G core. So it's not a native 5G technology, but as the requirements are fulfilled for broadcasters through the 4G, it's considered to be as a part of the 5G context. And as I said, it's an important technology in the 5G-MAGs, including the reference tools, to provide broadcast services. So the combination of LTE-based 5G with 5G services and the 5G framework is important. And this is important to remove some of this confusion. Is this a 4G or 5G technology? But also to make this technical gap bridging. And I believe both are relevant. And the latter one is something we addressed in the work item. And it's not rocket science, but it has a couple of aspects that are addressed. The basic idea that was put forward is that a content provider may leverage 5G unicast, 5G media streaming, 5G broadcast, and 5G built devices to build efficient, innovative applications. And that is supported by well-defined network reference points and client-side APIs. You can do different deployment and collaboration models, and there's different flavors exists of what is referred to as hybrid service. And I get to there in a second. So now building on top, and I hope that people apologize and don't come in completely blank here. This is basically the architecture that was shown by Thorsten before. So you have 5G media streaming, you have the reference points here, you have the interfaces here. So 5G media streaming over eMBMS architecture, the basic principle is to add eMBMS as a delivery option to distribute 5G-MS based services. So now, if you put this into architecture, you don't define any new interfaces, reference points, because you make use of XMB, user plane and control plane. You make use of the eMBMS APIs in the client, and then you just build this together, right? Now, why would you do this? There's a couple of ways how you can make use of this decomposed architecture, and we have documented in the annex a few options here. So the first assumption is that you have a 5G content provider using different delivery architecture. So take yourself as, let's say, I take BBC because Richard was participating. And now you operate, have content, and you basically run a 5G-MS AF and AS, and then you use now the 5G MNOs distribution network and somebody who offers a 5G broadcast network operation with a BMSC and distribute the content to UEs, right? And that UEs implement also a 5G broadcast LT eMBMS receiver and a 5G-MS client. So now you have interfaces to the MNO through M40 and M50, or basically here N6 more on the logical layer on the core. And you have the broadcast network operator. Now, I come back later how you can set up services, but that's basically one option. Another option is basically that the 5G-MS network operator now offloads to the 5G broadcast network operator. So in that case, again, you might have an application or media provider. This one basically just provides interface and communicates with the 5G-MS network operator who runs in a trusted domain AF and AS. But then the 5G-MS network operator, for example, collaborates with somebody who provides a shared broadcast network and enables to offload content to the broadcast MNO. So that might be your Super Bowl live service, or nobody watches Super Bowl here, maybe your World Cup or European Song Contest, right? So that data is potentially offloaded. A third case is where this 5G-MS service operator owns both. So that might be the case as well. There could be cases where you own a 5G network and an eMBMS distribution network. Again, the one owning the content would only communicate through 5G-MS interfaces into the network. And then there's another one where you basically have a 5G broadcast service provider who then collaborates with an MNO. So now you're operating here a broadcast network, you own the 5G-MS DAF and AS as functions, and then you're basically using NEF to use a 5G network, but you also own the broadcast. And probably there are even more scenarios, but that's basically the idea, that you have this modular ability of interface and reference points on the network to distribute also business opportunities across. In all cases, you have seen that the UE didn't change. The UE was basically the same, and the UE is decomposed also in this modular interfaces to make use of the system. So now we have done a couple of scenarios. And the first one is relatively simple, that you basically say, I exclusively deliver content through eMBMS. So I have 5G-MAG content, I just broadcast it. So in this case, you would not be using, sorry about this one, you would not use physically a unicast interface, everything goes through broadcast. And this might be a case where you have receive-only devices, as an example, and these receive-only devices might be just a subset of your devices, but potentially they are not unicast connected, be it for regulatory reasons, be it for reasons that there is no uplink available in the context or area. So then what we have done, and that's basically an extension to the first one, is that you say, okay, let's at least augment the pure broadcast distribution by a certain functionalities that are more on the uplink. Basically, you allow that you do consumption reporting. So at least you have information available in the network, how many devices are consuming the service. And you could go even further, you could do metrics reporting. You provide metrics on how well the service performs. So in this case, basically, you expose metrics from the eMBMS client or consumption reporting metrics and report this using 5G-MS-based functionalities as introduced by Thorsten. And at least 10.2 and 10.3 are already more or less supported by our reference tools, thanks to all the work done by Daniel and Johan and Klaus and so on and so on. So the next one, and that is now hybrid services. That's documented in 5.10.5. The basic idea is that you have a hybrid service where you use a basic service available over eMBMS, but you have it also available on unicast. And the service on unicast might be richer, might be extended, it might add additional user experiences. And for the hybrid use cases, initially, the content is statically provisioned. So on the network side, you provision it once, and then you make it available on different delivery networks. And there's a couple of instantiation of hybrid use cases. One is relatively simple. You do something interactive. The main content still goes through eMBMS exclusively, but you can basically interact with the service by maybe getting some overlays to getting some information that then is delivered to you through unicast. An important concept is session continuity, it's called, or coverage extension. There's a couple of different names for this. So here, the basic context is you're using eMBMS whenever it's available, but if you go outside of your coverage, you're moving to unicast. So that could be, for example, you're going indoor, your broadcast reception gets lost, and now the client basically switches to unicast. And by service offering as done, this is all seamless. It's the client's decision to move to make this viewing. There are other cases. You could do time-shifted viewing, right? So you basically go back in time on your live service, and now once you go into your time-shift viewing, you switch back to a unicast way of getting the content delivered. And then there are other more content or component replacement. So for example, you might have a targeted ad if you're in unicast, or you might get other targeted content, regional content, or specific content based on your filter, or you might replace your language and use unicast. As I said, the service offering is static. The logic and smartness is included in the 5G-MS client. Typically, in the play on the MSH, we had just a discussion before in our call. This is a bit of there's an interesting implementation aspect here. There's different flavors, interesting. The second one, that's basically now the umbrella of the previous ones, and that's probably the most complex. And we started to look into this also already in the 5G-MAG reference tools. It's in 10.5.6, you do dynamically provisioning the service. So the basic idea is you have resources of the broadcast system. They're statically configured. You have your TMGIs maybe, or you have at least resources available, a spectrum, a frequency band, and so on. But you use eMBMS distribution only for services in high demand. And this high demand, there's a lot of flavors that are basically up to the content provider. High demand might also mean that resource and quality of service distributed to broadcast may be adjusted according to demand. So if you have a service that 95% of my users watch, you might change not only that you put it on broadcast, you might also make it very robust, or you make it very high quality, and so on and so on. So there is different flavors, and you might dynamically provision this. And demand may be now identified through using this consumption reporting. Then there's a couple of options and variants. One is basically, do you do a one-to-one mapping between media service or 5G-MAG service and eMBMS user service? And then you just take on and off the media service, the eMBMS user service. But you could also do this, that you dynamically map media services to user services, or you only do it per component. That is another aspect. So at the end, that basically requires the same client implementation, because the client needs to understand these service offerings. But there is now an additional aspect that on the network, you also dynamically offer the content changes. And there's a complex workflow diagram, and I'm surely not going to go to this in the details, but there's a provisioning phase that provisions the content more or less, and make sure that you can offer so you initially offer your eMBMS services being set up, but then a content might be only delivered over unicast. And at the time when you detect high demand, you basically now provision that the service is moved to eMBMS. And then, or it's also available on eMBMS. And then you have basically, the client is announced this, and then you are aware of this, and the client now makes the selection. So it's clients that are able to receive eMBMS will move over. Those who are not able will stay on unicast, but that basically offloads demand. And if the demand on clients is ceasing and lowering, you can remove the service again. So there's a significant amount of dynamicity on the service provisioning as well. Just wrapping up on that one. So what is documented in 26501, which is the 5G-MAG, is a general description of what I discussed here in clause 4.6, 5.10, and Annex C. There is then stage 3 in the 5G media streaming stage 3 on the protocols. And there is there's basically a more detailed call flow, and we have extensions to support the different use cases on the APIs, the reference points, the consumption reporting. And then we have done small updates in the eMBMS specs, basically to connect it to 5G-MAG. You can signal what you get is 5G-MAG. When we look into the implementations, what needs to be done, right? So we need to basically look into a 5G-MAG-based service offering with consumption reporting. This is the case, so over eMBMS. No, so that is a general offering. So basically just on the reference tools, let's implement a very basic 5G-MAG-based service offering. Then you need the client MBS APIs as well as M6 and 7 to support the different scenarios. So that is basically exposing demands, instructing to switch to eMBMS, basically also more way policies enforcing. We need improved media players to support multiple delivery networks, as well as dynamically selecting and steering off the players to different networks. So if broadcast is available, you want to move the player to choose the broadcast incarnation. And another implementation is basically that there needs to be a dynamic service provisioning on the network side, taking into account the information and updating and changing service announcements. So as I said, I believe we are already in the process of implementing this in the reference tools. What would be excellent if you can verify and validate what has been documented in release 17. And if we identify gaps, move it forward as well. So this is just as probably a prominent use case that is already started to be supported. I thank you for your attention and very open to comments and questions. Thank you.
Thomas, thank you very much. So I think there's a lot of discussion in the chat for the presentations or Thorsten. I would suggest as well, like if companies have questions, please put them in the chat. And Thomas, if you can, maybe you can have a bit of exchange over the chat.
Yeah.
Thank you. Thank you very much. Very good presentation as well. So our next presentation is from Imed on Edge extension. So I think, yes, is the Edge applications for streaming. So Imed, are you available?
Yeah, good morning, everyone.
Good morning, thank you. Yes, we can hear you, thank you.
Yeah, so this is about another feature that 5G-MAG has added in release 17, in addition to the multicast broadcasts that we were listening to, and also the event framework that we'll hear about. But this is a cross group feature. Actually, it started in SA6 and SA2, SA5 also did some work on the management, and we're in SA4, we added support for Edge to 5G-MAG, and that's what I'll handle here. I'll have a few references at the end if you're interested to understand the whole picture. Again, thanks to Richard and Iraj and everyone who has contributed to the work. It has been a long journey, actually. So it started with a study item, which we called EMSA. And then this moved into stage 2 work, where the architecture has been defined, and you can see the architecture in the picture here. So basically, it's an integration of the Edge app or the SA6 architecture on Edge and the SA5 architecture on management. These two features are really, or these two architectures are integrated into 5G-MAG to enable things like discovering Edge and also setting up Edge resources on demand or on need basis. What we really added in SA4 to the 5G-MAG is the integration to the provisioning side, so basically extensions to the M1 interface through which the application provider can do provisioning. So it can, in addition to defining like its quality of service templates and things like that, it would also be able to define what Edge resources its sessions would require and which sessions are eligible for Edge resources. So you could say some sessions, if they meet certain criteria, they will need to connect to an Edge application server. And the Edge application server needs to meet certain requirements. So that's in short what this is doing. So again, everything is integrated in the MSH on the client side. So it has what we call an Edge enabler client. So that's part of the Edge app architecture. Its goal there is really to discover Edge resources by talking to an Edge configuration server and then an Edge enabler server. So once that procedure is done, so we define, for instance, we provide information over M5 that would help the EEC to discover like these Edge resources or the proper Edge application server through these the Edge one interface that's shown there. So it contains things like filters to limit the set of Edge application servers that meet these criteria. So the client will get a short list of servers or Edge servers that it can select from. So that's pretty much what we did. So extensions to M1 and M5. The way we did it is we separate or differentiate between two cases. One of them is the client-driven Edge session management. So in this scenario, the client is driving the session, so the client is aware that Edge resources are being used, so it requests Edge resources. Let me see if I can use this magnifier glass. So there is always like some pre-steps like application provider provisioning, for instance, indicating that certain sessions would require Edge resources. There is also like an internal like provisioning for Edge computing, Edge compute resources. So you can basically configure your data centers and spawn like new instances of the edge application servers and so on need basis. So you could think of like always an operator always trying to keep a certain amount of edge application servers up and running for a particular application idle state and waiting for some clients to connect. So that's anticipating like some connections or some sessions to be started by the clients for a particular application. So you could have some of these resources running in idle state and waiting for connections. Then once, in this case, of course, it's the client-driven approach. So it's the application that is aware and asks for particular or discovery of an edge application server. And then the MSH will help with that. So it receives information from the AF. It can invoke like requests to the edge enabler server or edge configuration server, and then edge enabler server to discover if there is an edge server that meets the requirements. And if not, then there is this optional step. If no suitable server with sufficient like processing power and that meets the network requirements can be discovered, then the application function, the 5G-MAG AS, may decide to invoke or spawn a new instance of that edge application server, and then provide that as part of the response. So once that is discovered, basically a 5G-MAG session can continue from there. So that's on the basically on the client-driven. The AF-driven is slightly different in the sense that this can happen completely transparently to the application on the client. There might be still some assistance or some knowledge or information exchange with the MSH, but really the application doesn't know that it's even talking to an edge server. So that's all done or managed by the 5G-MAG AF based on the provisioning information that it has received from the application provider. So whenever there is an eligible session that is discovered, so all the configuration is done on the network side to set up suitable or find a suitable edge application server, and then modify, for instance, things like the DNS discovery, so that whenever the application tries to resolve location of that server, it will point to the most suitable edge application server. So we differentiate between these two use cases. Of course, in practice, probably this AF-driven might be deployed more, depending on the configuration and the collaboration scenario. So it's easier, of course, to keep this or operate this transparently from the application. It requires like some configuration on the client side, so ability, for instance, to populate the DNS cache with suitable records that would point to the most suitable edge application server. But other than that, the application doesn't really need to be aware or needs to take special precautions to operate the session. But of course, these two are enabled, and we'll see which one at the end will be more successful or will gain more traction. We also have some initial support for application context relocation. Of course, when you connect to an edge application server, there are things that you need to take into account, especially when handling mobility or like changes in network conditions, availability of edge application servers. So an instance could crash or things like that could happen. So we have defined or classified applications into different classes. So some of them can handle a relocation. They are actually unaware that a relocation has happened. For instance, if you're talking to a CDN edge, it doesn't really matter which edge server served you the last signal, for instance. So the application is totally unaware of that. And as such, relocation can be performed without risk for the application. There are other applications that are aware but and can tolerate relocations, but they have some requirements. For instance, the downtime should not exceed certain duration, things like that. So there are requirements that would need to be guaranteed if a relocation process happens. That means if the edge application server changes from one to another, and these would need to be guaranteed by the 5G-MAG before such a relocation procedure is performed. And then ultimately there are applications which are completely intolerant. So say if you're playing a real-time game or something like that, and a relocation would require that you completely tear down the previous session, start a new one. So that comes with an unacceptable interruption to the user experience, and as such, the application provider would mark these sessions as a relocation intolerant. In such case, of course, the 5G-MAG would try as much as it can to avoid relocations. Of course, there are cases where this is not always possible. Say if the data network changes after mobility, like a handover, where the UE finds itself in a different data network that the previous local data network is no longer accessible. So the previous edge application server is no longer accessible. So in these cases, unfortunately, there is not much that can be done, and an interruption is unavoidable. But these are the classifications. We also define like these criteria for relocation. And of course, we don't specify exactly how the AF would or the MSH need to operate to keep or maintain these requirements. But there are ideas like, for instance, the MSH or the AF can perform like ping operations to the new EAS or things like that, or measure like the bandwidth, the round trip time, or things like that. So before making a decision on whether to relocate to a target EAS or not. So these are all like at the initial stage in release 17, and we're expecting that more work will be done on the application context relocation and the procedures related to that in release 18. So next steps, I think there are some obvious things that would need to be done, like these client APIs. So basically extending the M6 APIs to the application to make the application aware of the edge resources, enable it also to request edge resources. So that's mainly needed for the client-driven approach. So right now it's really realized with minimal intervention from the application. Basically, the MSH takes a lead role there, but we want to enable the application to have a say, basically, on that. For instance, if it receives a short list of edge application servers, maybe it's up to the application to select which one to pick and things like that. Adaptivity is another topic. So being able to monitor and use the information about the status of the AS, status of the network, and all of that can be, for instance, shared with the network, the data collection function, or it can be used to decide things like, should I relocate, should I spawn a new edge application server instance for the future clients and things like that. So all of that would be addressed in release 18 or beyond, but also things like, are there other edge frameworks that we need to support? What if the architecture is different than this edge app? For instance, can we operate or integrate in 5G-MAG other edge architectures like 5G-MAG or even proprietary things like Greengrass and so on. So these are questions that we'll look at in the future of edge. We'll also monitor what other groups and 3GPP are doing in the edge space and harmonize in order to come up with a solid offering for applications and services that want to use edge features in 5G. We already started looking at such use cases, and split rendering is one of these. So it's basically enabling high complexity graphics applications to run on the edge, and then have a relatively simpler rendering procedure on the device. So you could think of use cases such as remote gaming or things like that as potential applications. So you would run heavy game engines that do things like ray tracing and PBR rendering on the edge, because simply right now you cannot do these advanced graphics operations on a UE, and even if you could, this would probably be very power hungry and would not be practical on battery operated devices. So we started a work item on split rendering. We have a concept that's called media service enablers. So we want to design this to be a form of an SDK that application developers can use if they have a processing hungry application that they want to split the load and delegate the load to the edge. So they could use this SDK that will perform the rendering on the edge server. It will come with all the features needed, like discovering the edge application server, running the application there, connecting to that application and so on, negotiating formats and stuff like that. So that's one of the key use cases where we think edge would play, would be a required enabler. And I'm bringing this here as a heads up. We might be contributing this as a use case for 5G-MAG, and we will develop a bit on, or when we make the final proposal, of course, we'll have a refined proposal on how to implement this. But this could be something that we could build in this implementation, that we could build based on a platform like Kubernetes or something like that. We will add the provisioning and the discovery interfaces like the REST APIs, and we will run a split rendering application, running a game on the edge and playing it, basically controlling it from a mobile phone. So this could be a potential use case for an implementation. And with that, I just want to point to all the specifications, or probably this is not a full list, but key relevant specifications related to edge. So as you can see, several groups and 3GPP have been involved in this. So it's a very rich set of specifications that work together basically to provide this feature. And we hope to see this topic adopted by 5G-MAG and see how this would work in a real setup. And with that, I'll open up for questions, and thanks for listening.
Thank you, Matt. Thank you very much for this very good presentation. So, colleagues, if somebody has questions, again, put them on the chat. And Imed, if you also have the opportunity to reply to those questions over the chat, I think that would be, I think there was good discussion over the chat, so thank you.
Sure, I'll keep an eye on the chat.
Thank you very much. So, our next presentation then is 5G Multicast Broadcast Services, and I think that's Richard, my colleague from BBC. Richard, are you available?
Hello. Yes.
Hello.
Welcome
Thank you.
to from a very hot London. It's just 31 degrees here. But let me share.
Don't complain. Don't complain.
Let me share my screen. This is the one we want. Are you seeing what I'm seeing?
Yes, perfect.
Okay. Let me just hide this annoying banner. Right, very good. So, yes, so I'm going to talk a bit about 5G multicast broadcast services in this talk. And this is based on work that Thorsten and many others have done in the SA4 group with me. We heard earlier from Thomas about the LTE-based eMBMS system. This was an attempt to effectively create a new multicast broadcast solution that is more compatible with the 5G core and the 5G new radio system. So just as a reminder of the some of the more interesting bits of the 5G core architecture, obviously we divide the functions between control plane and data plane, or user plane as it's sometimes called. And in the control plane, we've got key functions like the service management function and the user plane function in the data plane, and obviously the 5G RAN system here, and the user equipment, which is your mobile phone. And so that core architecture was defined by the SA2 group. And then in release 17, they decided to add multicast broadcast functions to that. And they defined a couple of new ones, which I've highlighted in purple here. A multicast broadcast service management function and a multicast broadcast user plane function. So the service management function is concerned with managing the allocation of resources to multicast in the system, whereas the user plane function is dedicated to dealing with the actual data packets and sending them. And an application function or application service can make use of those directly. So SA2 has defined these two interfaces, the NMB13 interface, this reference point here, for controlling things, and the N6MB reference point for injecting packets. And if you've got a very simple use case, you can just use those reference points directly, or if you're outside the trusted domain, you can go via the network exposure function and sort of control it via this kind of proxy. And then importantly, the service management function can also control the policy and charging for multicast broadcast services through this new N7MB reference point. And as I say, if you've got a simple use case, you can just do that. So for example, if you're generating packets for some kind of emergency services, communication network, you can interface directly at those reference points. But for most uses, we think that some kind of higher order user service is needed to manage that. And the SA2 group additionally defined these green functions and reference points to manage the user services, and they sit in front of those two purple functions. So we have the MBS function and the MBS transport function, and they have their own reference points, NMB10 and NMB8, and then they talk to each other a little bit over NMB2, and you can still go outside the trust domain and interact via the NEF proxy using this NMB5 reference point. So these two green functions were defined by SA2, but they left their specification, this 23247 specification, at that, and they asked SA4, the SA4 group, to flesh out those functions and those reference points. So that's what really this talk is about. And so in SA4, what we did is we've created this higher level model called MBS user services. So you see the MBSF as before and the MBSTF as before, and then they have their counterparts in the client space. So there's this MBSF client that talks to the MBSF, and there's an MBSTF client that talks to the MBSTF. So it's all very straightforward and simple. These functions in the UE effectively combine to form this MBS client, and that could be a piece of middleware that's running on your mobile phone, or it could even be a separate application. But ultimately, you need some kind of MBS aware application that's going to make use of these services, and there are some client APIs, MBS6 and MBS7, for controlling these two functions in the UE. So the last bit of the jigsaw that's missing, I haven't talked about, is this MBS AS, and this is provided as a means of doing unicast repair when the main multicast broadcast service proves unreliable, perhaps because you're moving around and you've dropped some packets, or some other reason. But the MBSTF client can repair anything that's missed over this MBS4 UC reference point. So that's the basic reference architecture there. So then there's a kind of domain model that we've defined in our 26502 spec that talks about various different sessions that happen between all these different actors in the system. I can quickly go through a little walkthrough here. So I've numbered the points. So firstly, the application provider provisions this thing called an MBS user service, and in fact that's actually comes in two parts. There's a kind of a high level umbrella thing, which is the MBS user service, where you define various high level aspects, like the metadata for the service, its name, and maybe even some external identifier. And then the second level involves provisioning what's called a user data ingest session, and all of this is this interaction with the MBSF. So so that's the first two steps. And then there's a third step where this MBSF starts advertising the user service session to the client. So it says, this thing is available. And then the fourth step is that the data starts getting ingested from the application provider by the MBS transport function. And then fifthly, it starts to distribute that to the MBSTF client. So then at some later point, the application decides it wants to start receiving that session. So that's the sixth step. The seventh step is that the MBSF client then starts receiving the user service. And then there's a little bit of interaction between the application and the client to control what it wants to receive. And then finally, the actual user data starts that has been received by the MBSTF client is then passed to the MBS aware application over this application data session. So that's kind of how it all fits together. And just to add that this interaction here could be some low-level socket, or it could be something like an HTTP proxy server exposing stuff to the MBS aware application. So to support all this, we've got an information model that sits inside the MBSF, and this is essentially just a different way of showing the same information that I was just describing on the previous slide. So we've got the MBS application provider here that does this two-step provisioning thing. So there's a user service and the data ingest session. So you can see that there's a bit of metadata in the user service, and maybe some external service identifiers. That could be something like a DVBI service identifier to cross-reference some other metadata service. The data ingest session indicates some active period, so you can automatically start ingesting between the hours of 8 PM and 10 PM every day, if that's when you want your service to be available. And then within each of these user data ingest sessions, there's a set of MBS distribution sessions, and they contain information like the MBS session identifier. That's the equivalent of the TMGI, the temporary mobile group identifier that was used in eMBMS. But it can also be just a simple source-specific multicast address in release 17. You can even target particular service areas for your distribution session if you want to. You declare a bitrate and various other different parameters, maybe some forward error correction. And then when it's time to advertise it, there's a two-level advertisement. So there's a high-level user service announcement with some of the information from the user service and elsewhere. And then there's a lower level distribution session announcement for each of the distribution sessions that make up your user service. And the basic idea is that the MBSF client is the thing that's consuming this high level information, and that maybe allows it to tell the application.
Hello.
Hello.
Hello, can you please mute yourself if you are not speaking, please? Thank you. Please continue, Richard.
Okay. Yes. So this high-level user service announcement is consumed by the MBSF client, so that it can maybe pass the name to an application so that you can select between the different available services, simple ideas like that. And then the low-level information, including what would go in the SDP, is consumed by the MBSF client. So that's basically how it fits together. And within this, we've defined two distribution methods, two different ways of distributing MBS content. The first one is this object distribution method, and that's for distributing things like HTTP objects. That might be, I don't know, dash segments, for example, or HTML pages, all sorts of things that are object-based would use the object distribution method. And we've specified the possibility of either pushing those objects into the MBSDF or getting them to pull those objects from some external web server. And then within the distribution method, there are 4 different operating modes that we've defined. One, just a single one-shot file that you send, and that's particularly suited to that push-based model. Because then you manage the complexity outside the MBSDF. There's a collection that you can define with a manifest. So that could be, for example, an HTML page and some images that go with it, style sheets, JavaScript libraries, whatever you want to send. There's a variant of that called carousel, where you regularly repeat a collection, and you can even get it to automatically check whether the files have changed when you're using pull-based ingest and automatically update them in the carousel. And then finally, and perhaps most relevant, the object streaming operating mode, where you provide a presentation manifest, like I don't know, a dash MPD or an HLS master playlist, and the MBSDF automatically fetches the objects, or you push the objects in at the right time and it sends them. So that's the object distribution method. The other thing that we've defined is a packet distribution method, which is a much simpler, lower level way of accessing the system. And that supports unicast packet ingest, perhaps over a tunnel. And within that, there are 2 operating modes. There's a proxy mode, where essentially you provide UDP packet payloads, probably unicast ones, and they get converted into multicast by the MBSTF and sent downstream in new packets. And then there's also a forward operating mode where you can tunnel your multicast packets that you've generated inside a unicast tunnel, and they just get forwarded unmodified to the downstream system. We haven't specifically defined a mode for RTP in case you're interested, and that was a question you might have had, but we've said that you can use either of these operating modes of the packet distribution method to achieve that effect. So this is a kind of a protocol stack view of how the MBSTF, this green part, works. And so for the object distribution method, we just illustrated here the pull-based method and the push-based method. And the only difference between the two is that in the pull case, you issue a get to the upstream web server and it responds, whereas in the push case, you're just directly pushing items onto the MBSTF. In both cases, the MBSTF is effectively translating HTTP unicast into it's a flute-based protocol in release 17, and that's sent over IP multicast packets. So that's pretty straightforward. And this is just a picture of what's going on inside the MBSTF for that case. So it ingests those HTTP objects, either pushed or pulled. It segments them into some other smaller chunks. It might apply some FEC to those chunks, and then it takes the chunks and the FEC block, the FEC repair information, and packetizes it into multicast packets, and then it schedules those multicast packets for transmission at a particular rate, depending on whether it's in carouseled or just single shot, fast as possible. So that's the object distribution method. And then for the packet distribution method, well, there are just a couple of illustrations here that show the difference between the two operating modes, the proxy mode and the forward-only mode. So in the proxy mode, you can see these simple UDP packets are being ingested by the MBSTF, and the UDP headers can be restamped here, and you have a new UDP packet to send over multicast. Whereas in the forward-only mode, you've got this extra tunneling layer, so you can produce your own IP multicast packets and then tunnel them inside a unicast UDP packet, and then the MBSTF will unwrap those and just send your IP multicast packets over MBS. These figures, by the way, are all in Annex B of the 26502 spec. Yes, this is a slightly simpler view in this case of what's going on inside the MBSTF. You're ingesting packets. You might be optionally adding some FEC to those. You packetize, and then you schedule the packets for transmission. So as Thorsten, I think, mentioned way back at the start of today's session, that there is an ambition to define the delivery of 5G media streaming services via MBS, but that's not something that we've had time to do in release 17. So that's an ambition to add in release 18. So very similar to what Thomas Stockhammer presented earlier about layering 5G media streaming over the eMBMS multicast broadcast system. We envisage that something very similar could be done to put 5G media streaming sessions over this new multicast broadcast system that's been defined in release 17. And similar to the other talks, here's just a list of the relevant specs. Most of the stuff that we've done in SA4 is in this new 502 spec, that's the stage 2 architecture, and then the 517 spec has got all of the protocols and formats defined in it. But there's plenty of other specs. This was again a piece of work that was done across, in this case, 4 different groups. So there's plenty of other specs that describe stuff as well. And that, I think, is me done. Yeah.
Thank you, Richard. Thanks very much for the good presentation. So as well as with other presentations, colleagues, if you have questions, put them in the chat. I think there are already some questions in the chat. Richard, you have then later time, you can maybe check the chat.
Okay, is anyone recording these questions?
Sorry?
Is anyone recording these questions anywhere?
No, they're in the chat.
Yes, but they'll be lost when the session ends.
No, yes, this will be, the chat is saved.
Oh, is it? Okay, cool.
Right, so just a bit of organization. So we have two more presentations, one from Richard and then one on event exposure framework and on XR. And then there will be, I will use the last 5 minutes to present the next steps, what companies need to do to submit the use case. So we are running a bit of out of time, but I think so. The next presentation on event exposure framework, Richard, I think is you as well. If maybe we can try to maybe summarize a bit, that would be great. That would be useful. Thank you.
Okay, I'll try and speed up. So yes, thanks. So this is a slightly peculiar topic, but it will hopefully become clear. It's work that I must thank my colleague Chales Lowe from Qualcomm, who's done a lot of work on this with me as well, and many other colleagues in SA4. Again, this work originated in SA2 group. So in their core architecture spec, which is kind of like the big, thick Bible thickness spec that defines the 5G core. They defined this thing called a network data analytics function. And the idea is that collects data from various different network functions in the 5G system, including potentially from application functions. And then it exposes what you might call analytics metadata to other network functions in the system. And the idea is to just get an idea of what's going on in the 5G system and how could it be improved from an operational point of view. That's kind of like the thrust of this NWDAF, the network data analytics function. So that was the basis of everything. And then in their 23288 spec, they further defined this a bit. So you can see that there's this concept of an event producer and an event consumer. So this network function acts as the event producer. It exposes events to the NWDAF, which consumes them. It turns the information into analytics and then exposes that to a data analytics consumer. So that's all very good. And they had some ideas about the sort of things that they wanted to do. One example, just as a concrete example, is called the network service experience by UE. So for example, if you're moving around with your mobile phone can record the quality of the signal that you're receiving, and then it can potentially report that, and you could do some data analytics on that to improve the quality of the network. So while SA2 did have this idea of collecting information from UEs, the 23288 spec didn't really explain how to achieve this, and they deferred the work to the SA4 group that those of us on the call presented today are members of, and so we had a look at what to do, and this is what we ended up doing. Well, it's a slightly simplified version anyway. So you've still got this NWDAF consuming events and exposing analytics to a downstream network function. But what we did is we defined this thing called a data collection AF, and that acts as an event producer for the NWDAF, and it exposes events to the NWDAF. And then in order to populate that, we defined this thing called a direct data collection client, which sits in the UE and reports data to the data collection AF. So that's all great. However, we also realized in SA4 that there was more interesting things that we could do in addition to what SA2 had asked us to do. So, for example, we realized that we had these things called application servers, and we've seen an example of, well, several examples of that in the earlier talks today. And these have their own application logs, which is essentially a different form of UE data that's collected by the application server. So we wanted to be able to allow them to report in as well as the UEs. And we also realized that there might be other interested consumers of these events, not least an application service provider. So we defined this thing called an event consumer AF to generalize the idea beyond just the network data analytics function. So in this case, an application service provider might want to do its own data analytics that are more related to some other reporting domain. So I'll probably skip over this, but you can certainly have a look at this afterwards. But there's a kind of a walkthrough of the processes that you need to do to make use of this service. First of all, provisioning it, then some event consumers subscribing to an event that it's interested in, then the direct data collection client in the UE getting some configuration, working out what information it needs to collect and report. And then actually doing some reporting, and then the data collection AF has a load of data processing rules in the form of some data access profiles, and they can control, restrict who can access the information, and you can also specify preps that you want to summarize information, calculate a long-term average, and so on and so on. And then finally, the information is exposed as an event to the downstream subscribers. So that's basically the walkthrough there. Now, one of the reasons we wanted to do a good job of this was because we realized that our own 5G media streaming use case could take advantage of this. As I think some of the earlier presentations have explained, we already have some reporting that's done from the media session handler to the 5G-MAG application function. And the 5G-MAG application function can, for example, log when various different features are used. So, for example, when the dynamic policy is invoked by the media session handler, we can log that in the 5G-MAG AF, so that can be exposed as an event. Similarly, when the media player consumes media from the 5G-MAG application server, we've got the equivalent of a CDN log entry for each of those accesses, so that can be reported to the data collection AF. So what we've done is we've instantiated the data collection AF inside the 5G-MAG application function, and we've instantiated the direct data collection client inside the media session handler. And so we've effectively created the first instantiation of the data collection and reporting architecture, and then we can expose that information to the 5G-MAG application provider as well. So that's what that is basically saying. And this instantiation is in the main 5G media streaming stage 3 spec 26.5.12. So we also envisage further instantiations of that generic architecture. So, for example, the 5G multicast broadcast services stuff I was just talking about could make use of a different instantiation. So in this case, the MBSF is acting as an application function, and so we could use that to collect UE data and expose it. And the MBSAS, this thing that does unicast repair, is just another kind of data collection client with its own application log. So that could be reporting to that data collection AF and the MBSF. So that's just a different instantiation. And similarly for Edge, the stuff that Imed was talking about half an hour ago, we might want to record additional events in the 5G-MAG AF to do with the client-driven edge computing that he was talking about. And you may be able to think of others when you describe your own use cases to us. So similarly, that's just a summary of the different specs. And most of this stuff is in a new stage 2 spec called 26.5.3.1. That, as well as the stage 3 spec in 26.5.3.2, is due to be published imminently. All of these release 17 specs that we've talked about today have been updated recently, and were approved at SA96 plenary meeting about a week ago, and they will be published imminently on the 3GPP websites. We've just been checking over drafts for the past week, but they're due to appear very soon. And that's me done. Thank you very much.
Richard, very good presentation. So, okay, so I think we can then jump to our next technical presentation, and that's extended reality. And Thomas, I believe that would be you.
let me see, where is the sharing? Can you see screen?
Yes, we can see. Thank you.
Okay, so this is really a teaser. Very. I have not uploaded slides that I don't know. I have some issues uploading, but I will do this after the call. So 5G and XR. So there was some initial work in release 16, release 17. There's quite some work release 18. Again, really just an introduction. I have a few slides in the beginning just to give you a bit of a perspective. I mean, what has been the case is that you're basically moving into this world where the environment where the world becomes your desktop, right? So we have spatial XR compute. A lot of aspects are location. So you're outside in the world. You recognize spatial compute information and so on and so on. So that's kind of the umbrella of the XR. And there is another aspect that is very much discussed, is the metaverse, right? Which is XR as a technology, which includes new formats that include spatial computing. And then there's, if you go deeper, right, technologies that include then edge processing, running massive amount of data over the network and so on and so on. But then also components, you know, from the internet, from social aspects, and the idea of being an open environment. All of this contributes to the metaverse, right? And 3GP is not like a single approach to XR or saying metaverse. There's a study on mobile metaverse in release 19 right now in essay 1 that has been started. But it's more like contributing and developing technologies in this area. So, and there's also an industry consensus on this metaverse XR, that there should be standards, right? Or openness supported by common exchange formats, common network protocols, APIs, common mapping data, and so on and so on. But it's not expected that a single organization will do this. I mean, there's some comparison to what was done for the web, right? With what was done through HTML and the development of browsers, but the browsers and all of this also heavily benefited from work being done in connectivity, then done in Wi-Fi connectivity, in 3GP, internet-based services, and so on. And then also open source environments, right? AR Cloud, open source, Linux Foundation, and so on. So there's an expectation of standards are needed across the board. Right? So then there is also, and that's where it connects a bit to the 5G aspects where have been analysis. So we're talking about new devices, and new devices are basically HMDs type of things, or glass, something like this. And this is a reference design. And interesting enough, a glass like this, including a lot of compute, would require also a very careful design in terms of what processing is allowed. One of the key issues is you don't have area for heat dissipation. That means you need to operate on very minimum power. 500 milliwatt is very often set as a target for glasses of which you can consume. So this is very low. If you're a bit familiar, 500 milliwatt is very low. So you're basically looking also into architectures where you feed new devices, and what's happening is basically that you're using potentially today direct connection between a PC to an HMD, but in the future, you also integrate your phone, connect your glass. And then there are also cases that you reduce the size, so that is still like an enterprise, so getting into smaller devices. But then there is ideas to basically that the phone connects through 5G and then connect to the glass. And then you have ways that you basically potentially in the further future that you have a direct connectivity to your glass. So this is something which are architectures that are studied, and now you need to consider on how you basically create workflows such that media and can flow, that you basically also do discovery, connectivity, and so on and so on. What we did in SA4, we defined frameworks for XR and a bit more specific from AR. Don't expect me to go through these details, but it's basically, there's aspects here which decomposes the device into something that is the AR runtime. This is typically supported today by AR Core or OpenXR as a more standard. So a runtime giving you the ability to physically connect to the peripherals, cameras, sensors, and so on. Then you have a very GPU-centric environment, right? So where you do rendering, and then you have functions for compression and delivery running over the network. And then you have on the network supporting functionality as well, because you using, as Imed presented, functionalities that are compute on the edge, and that basically allow you to offload because you only have a limited amount of processing resources available. So there are workflows, and then there is also basically requirements that are documented here. Requirements for that allow you to be giving you a sense of presence and immersiveness, where you have latency requirements, and there's latency requirements that are provided to you just to feel presence. Very often referred to this 20 milliseconds motion to photon latency. 20 milliseconds is very challenging. So you can compensate some latency, last minute latency, late stage reprojection in the device, but still there are requirements that require you to run latencies for between where you render the media until it's presented of something like 50 to 60 milliseconds. And now you can distribute this and can basically identify how can you set up this in physical connections? How can you make use codecs? How can you basically make use encoders? How you can render in the network? How can you use 5G functionalities on the system, the radio, to support these type of use cases? So there's a whole framework that looks into how you set up connectivity, how you distribute the processing in two technical reports referred to here out of release 16 and 17. Release 18, what we have started now is to document basic capabilities of a device like this. So what do you expect? What media, what functions need to be supported from a content delivery and so on. So we know that there will be a 5G system support, but also from a media, and that's documented here. And we have started in release 18 of going at device architecture that is a simplification of what you saw before, but with the idea to really specify requirements across the board. So now the last slide just on that one. I mean, what would it mean towards interop reference tools for XR and the metaverse? And I believe there is not a starting point to say we know what we need to do. The first aspect is identify use cases and scenarios, right? What device are we talking? Are we going to a phone, a VR HMD, an AR glass? It's an AR glass that is a consumer and enterprise, right? This is very, very case. There's use cases from delivering, streaming, something we do more today, right? To cloud gaming, conferencing. You could also think about XR production cases, right? How can you integrate this? How does it relate to 5G QS requirements? And QS is very broad here, bit rates, latency, very specific cross-layer APIs and so on. So there's work now starting in 3GP on this one is edge enablers, media requirements, media capabilities. Towards going there, I believe what is important is that we identify what exists, what are available reference frameworks towards XR metaverse, test material, assets, scenes, content generation framework, game engines, Unity, Unreal, how you can basically make use of these type of things. Reference applications, games, conferencing, streaming applications, reference devices. What exists today, I mean, you can buy a HoloLens, a very expensive device. This is the reference design. What are the APIs? Runtimes for this renderers, AR runtimes, XR gaming-centric runtimes, and so on. I believe it's worthwhile that 5G-MAG at some point looks into this, and but I also believe 5G-MAG may partner with other organizations. We expect to have an announcement next work on new organization that is not the standards developing, but coordinating. So stay tuned on this one. And I believe what 5G-MAG should bring, the 5G-based media distribution reference tools and environments to this one. And I consider this very long-term, but I mean, there might always be a good time to start. I leave it at this. Thank you. Right? Maybe go back here.
Thank you, Thomas. Yeah, this is a fascinating topic, getting a lot of traction in the industry. So yeah, I really, I'm very interested on these last 2 points you mentioned about what can we do in 5G-MAG and when to start, when is the right time to start. So thank you. So take conscious of the time. So I want just to explain the next steps, what companies need to do to submit a use case. So let me share my screen. So let me just, Jordi has also shared some the details, but everything is in the website in 5gmag.com target 2023. So there we will store the presentations from today, as well as the videos and all the all the information. But then you will find here a form that is a very basic Google form that then you could fill. So it's just some fields such as the name of the use case. I hope you can see my screen. Yes, you can see my screen. And then there is a high-level description. So for instance, you could provide, it's a high-level description of a use case, like what type of content you are thinking, live, on demand, what type of devices, it's a smartphone, what type of networks. So the idea is to provide a high-level description. So to submit your use case, the only mandatory fields are the name and the high-level description. It's also possible to upload a file if you want to provide a figure, a supporting document for this description. That's also welcome, but not mandatory. But if your company then is more ready and has already an idea of which technology features and support that use case, then you also have the field that you want to provide additional information. But that's not needed. That's not mandatory for the first stage. So we would like to have as many use cases as possible. There has been comments on the chat about whether 5G-MAG should consider. My point is just submit, even if it's just something short, and I think it's better you submit something and then we can discuss whether there is something missing or the technology components. We have discussed today, a lot of the presenters have shown a lot of technology features. We don't need to constrain to those. Those are very good examples to start teasing some thoughts on you, but other technologies could also be considered. So here we have also provided some examples, and you can maybe as well check in your own time. So for instance, this is just, for instance, an example, so to provide more guidance and to see that there is the process to submit something is quite straightforward and quite easy. So for instance, 5G broadcast broadband seamless switching, this is something is implemented in the reference tools. So you could, I mean, a description could look like something like in the screen, like a user would like to receive linear live content uninterrupted in their smartphones everywhere at any time. And then from the service provider point of view, to provide universal coverage, they would like to allow seamless switching between broadcast and broadband, so where the users are out of coverage in a 5G broadcast signal, then they can still receive the signal from unicast, and then the quality of service is maintained. So as you can see, it's quite a high-level description, and then we can dive in later discussions into the technology features that are needed. And then another example here, just to provide more guidance, for instance, media streaming via mobile networks with defined quality of service. So for instance, a description could look like a user wants to receive an on-demand live video service with high quality of service outdoors. And then from the service provider point of view, that usually relies on over the top without just best effort, without guaranteed quality of service, now wants to specify a specific quality of service for an event, for instance, a football match, a live football match, and that wants to be delivered as a configured quality of service. And this, for instance, is what Thorsten was explaining on these profiles. So as you can see, this is an example. So you can provide whatever you think is relevant. So just to conclude, the next call will be call number 2, 8th of July. So those that are registered for this call don't need to register again. They will receive the invitation. So we have put here a deadline for submission of the use cases on the 6th of July at 11 a.m. UTC, 1 p.m. Common European Summer Time. This is as well to help the organization to process the information before the call. So cases submitting after that will be also considered, and we may need to treat them with lower priority just to so please try to make the deadlines also help us to process the information in time. So as well, any question, just please reach out. You here have the email address, and you can contact any of us. And the key point is now try to get as many input from the industry as possible. So please provide your input and thoughts. So with this, I would like then to thank all the speakers and all of you as well for attending and keeping as well until we have run a bit of time, but I think it has been very useful. So thank you very much all, and hope to see you in the next call. Thank you.